Hey guys, today we're moving on to 11.2. So on Friday we had talked about quadratics, and I introduced you to a parabola and all the different things that happen from a graph. Today we're going to talk about attributes of quadratics from standard form. And we've talked about standard form before when factoring, when we did those x puzzles. Remember, standard form is ax squared plus bx plus c. And you can always tell what your a term is because it's next to your x squared. You can always tell what your b term is because it's next to your x. And then your c is just your constant. It's over here by himself. So we've talked about that. We did x puzzles with it. That's standard form for quadratics. So you are a little bit familiar with this. Some reminders from Friday. Some of the things we talked about was if your a is greater than 0, aka if your a is positive, your graph is going to open up. So if that a term, this term right here, is a positive number, then your graph opens up. And if it opens up, that means that your vertex is way down here, which means that is the lowest point on your graph. So it is a minimum. Vertex is a minimum. Now, if a is less than 0, aka it is a negative, so we're talking about this a term again, if this is a negative number, that means your graph is going to open downwards. And then you've got your vertex way up here, which is actually the highest point on your graph. So now you've got a maximum. Maximum. So again, we talked about that on Friday. Up is a minimum, down is a maximum. Then we had pictures of graphs, and we were able to find these different attributes. So the first one down here is your vertex. In this case, since it's opening upward, we've got a minimum. It is the lowest point on the graph. Then we've got our y-intercept. That's where our graph crosses our y-axis. So our y-intercept would be right there. We also have x-intercepts, which aren't labeled here, but that's where it crosses the x-axis. So in this case, we have 2 of those. And remember, we've talked about how many solutions, zeros, x-intercepts, remember those all mean the same thing. For quadratics, you can have one solution, it crosses your x-axis one time. No solutions, it doesn't cross at all, or 2 solutions like you see here. Then lastly, we talked about our axis of symmetry. That means that if I cut it right down the middle of that vertex, the left side is identical to the right side. If I fold it along that green line, they would match up perfectly. They are identical. So again, this is our axis of symmetry. And it's always written as x equals a number. And remember, we get that number from our vertex. So if our vertex is x comma y, we use this x for the number up there. So that's the number. So we were able to tell all those things from the graph. We also know that domain for quadratics is always, always, always negative infinity to positive infinity or all real numbers. And the range depends on if it's facing upward or downward. And that's dependent on this y right here. So standard form, if I give you an equation in standard form, I'm not giving you a picture of a graph anymore. These are the things you can find if I give you an equation in standard form. You can find the vertex, you can find the y-intercept, you can find the axis of symmetry, the domain, always, we know what that one is. You can find the range, and either if it's a maximum or a minimum. The only thing you can't find from just the equation is your x-intercepts and zeros. So how do we find the y-intercept? So again, that's where it crosses the y-axis. This is going to be your c term. So in that standard form, and again, that's the term without an x. So if you have standard form like we did above, ax squared plus bx plus c, we're talking about this c term. And if it's on the y-intercept, think about it. Here's my x, here's my x and y axis. If I am on this line right here, that means I'm not moving any to the right or to the left. So it's over 0, and then it's going to be whatever your c term is. So in our case, your answer is going to look like 0, comma, c. And again, you're getting that c term from that last term. Okay? Axis of symmetry. You use this formula, x equals negative b over 2a. That's how you're going to find it. And again, you're using your a from standard form and your b from your standard form. You're just plugging in those numbers. Vertex. You use the negative b over 2a, that's your x term. Then you're plugging it back in to this formula. So you take this, plug it back in here, and whatever you get out is going to be that y term. So your f of negative b over 2a. And again, that just means we're plugging it back in. Then how do we find if it's a max or a minimum? Well, max or min determines on the a value. So if a is positive equals a min, a is negative equals a max. And you're also using that y value from above. So this term right here. Y value from above. So it'll be like a minimum at y equals whatever that term is, or a maximum at whatever that term is. Range is going to be if y is either greater than or equal to whatever your min value, and again, that's if your parabola is facing upward, it's a min, or y is less than or equal to whatever your max value is, and again, that's if your parabola is facing downward. Lastly, domain. Is always negative infinity to positive infinity, or you can write the all real numbers. But it's always that. Okay, let's try some examples now. So again, I'm giving you an equation. Let's look at number 1. You have the equation. Your y-intercept. Let's do that one first. Remember, that's this term right here, your last value. So it's always going to be 0, comma, whatever that is, and it's 1. So there's your y-intercept, 0, comma 1. To get your axis of symmetry, remember we have to use that formula from above. This one, x equals negative b over 2a. X equals negative b over 2a. And remember, we've got 3 is our a this time. And negative 12 is our b. So when I go to plug this in, I've got negative 12 over 2 times 3. Okay, well, a negative and a negative makes it a positive, so I really have 12 over 2 times 3 is 6, which is 2. So x equals 2 is your axis of symmetry. So that's where you would draw the line straight down at 2. Vertex. So to get your vertex, this first number comes from here. The second number, you're going to plug 2 into your formula. So remember we had y equals 3. Now I'm plugging the 2 in for x. Minus 12 times 2 plus 1. You can solve all that out, or again, you can plug this whole thing right here into Desmos. So I've got 3 times 2 squared minus 12 times 2 plus 1. And when I get it out, I get negative 11. So all of that equals negative 11. So that's what's going to go there. So that's how you get your vertex. Whatever your axis of symmetry is, the 2 goes first, and then you plug that 2 back into your original equation in standard form to get negative 11. Okay, max or min. Well, notice if I look at this, the A is positive, right? So I know that this parabola is going to be facing up. That means that the lowest point is my vertex. So this is actually going to be a min. And the min is at y equals whatever this is, negative 11. Whatever that y value of your vertex, because that's the lowest point, right? Okay, range, since it's a min, it's going to be y is greater than or equal to, everything's above that, negative 11. Domain is always, always, always negative infinity to positive infinity. And there you go. That's how it's done. So let's do another one. 2. Y-intercept, again, I'm looking at this value here. So when I do this, it's always over 0, and then it's negative 4 is that C term. So there's my y-intercept. Axis of symmetry, I'm going to be using the formula x equals, actually I think I did that in green. X equals negative b over 2a. And again, in this case, a is 1 because there's nothing there. It's an imaginary 1, right? And then my b is a positive 7. So when I go to plug all this in, I've got negative 7 over 2 times 1. So I really just have negative 7 over 2. So for my axis of symmetry, I've got x equals negative 7 over 2. When I go to do the vertex, it's going to be negative 7 over 2. Again, I'm getting that from this, comma. I've got to go plug back in. So I use y equals negative 7 over 2 squared plus 7 times negative 7 over 2 minus 4. And again, I'm going to plug that whole thing into Desmos. Going to cheat a little bit. Negative 7 divided by 2, square that whole thing, plus 7 times negative 7 divided by 2 minus 4. And I'm going to turn that into a fraction. The other one's in a fraction, so negative 65 over 4. So I'm using this right here to go here. So that's my vertex. Then I look to see if it's a max or a min. If I look at my A term, remember the A term is positive, so this would be facing upward. So that means it is a minimum at y equals whatever this term is, which is negative 65 over 4. Again, the range is going to be y is greater than negative 65 over 4. Using this again. And then lastly, domain is always, always, always negative infinity to positive infinity. Or again, you can always write all real numbers. So not too bad. The only difficult part would be probably this part here using the formula, which again, you get to use Desmos, so it's not terribly bad, I don't think. Let's try another one. So number 3, y-intercept. Again, I'm using this c term. I'm on the y-axis, so I'm not moving any on my x, so it's 0, and then I'm going up 12. That's my y-intercept. Axis of symmetry. I use the formula x equals negative b over 2a. This case, I've got a is 2, and b is 10. So then when I go to plug all that in, I've got negative 10 over 2 times 2, which is really negative 10 over 4. And I can divide top and bottom by 2, so I'm going to have negative 5 over 2, and you can just leave it like that. So axis of symmetry is x equals negative 5 over 2. Or you could say negative 2.5 if you want to do decimals. Vertex. I'm using the negative 5 over 2 from here. I'm plugging it back into y equals 2 times negative 5 over 2 squared plus 10 times negative 5 over 2 plus 12. And again, I'm going to plug that whole thing into Desmos. So go to Desmos, and I've got 2 times negative 5 divided by 2. Square that plus 10, times negative 5 divided by 2 plus 12. And I get negative 0.5 or negative 1/2. So this is equal to negative 1/2. So I'm going to use this here, come down here, I've got negative 1/2. Max or min, again, I look at that a term. Since my a is positive 2, my parabola is going to be looking like this, facing upward. So this is going to be a min. My vertex is the lowest point on my graph at y equals negative 1/2. The range is going to be y is greater than or equal to, again, it's facing upward to that negative 1/2 from above. Domain is always, always, always negative infinity to positive infinity, or you could write all real numbers. And let's do number last. So notice this one only has 2 terms. So if we were to put this in standard form, we would need to add 0, right? That would be your c term. So if we're looking at the y-intercept, I'm looking at that c value again. Just because this term's the last term that they wrote, that is not my c term. C term's by itself, it doesn't have any x's with it. So if it's not there, it's 0. So in our case, we're going over 0, and then we're going up 0. Axis of symmetry, we're going to use our formula again. X equals negative b over 2a. A this time is negative 3, and b this time is 24. So when I plug in, I've got negative 24 over 2 times negative 3. Negative divided by negative gives me a positive, so I really have negative 24 over 2 times 3 is 6. Oops, didn't remember to write that negative there. Then I have 24 divided by 6, which is 4. So my axis of symmetry is x equals 4. The vertex, I'm going to use that x from above. So that's my first number of my vertex is at 4. Then to find the second number, I've got to plug back in y equals negative 3 times 4 squared plus 24 times 4. Again, I'm going to plug this into Desmos. And I've got negative 3 times 4 squared plus 24 times 4, which is 48. So the y value of my vertex is 48. So if I look if it's a max or a min, I'm looking over here at this a value. This time it's a negative 3, so I know that my parabola is facing downward. Right? Whoop. Facing down. So that means that it is going to be a maximum. My vertex is the highest point now at y equals, oops, that was supposed to be 48, wasn't it? Okay, at y equals 48. Range, since it's a max this time, everything has to be less than or equal to that 48. Again, using that same 48. Domain is always, always, always negative infinity to positive infinity or all real numbers. And that's standard form. Now, since we do have Desmos and you are kind of able to look at characteristics from graphs, you can graph these equations into Desmos. So if I looked at this first one, and I took this whole thing and graphed it into Desmos, y equals and everything. So y equals 3x squared. Ooh, I'm in all caps. Y equals 3x squared minus 12x plus 1 equals. There we go. There is my parabola. So from here, you can kind of see where everything is at. You can look at your vertex. I can click on it. Oops. Go away. I can click on it. My vertex is 2, negative 11, which is what we got over here, right? 2, negative 11. So axis of symmetry would be that 2. I can look for my y-intercept. I can click where it crosses the y-axis. So right here at 0, 1, which again is what we got, 0, 1. So you can also graph like that and kind of see what's happening with the graph. I highly recommend you do it. Desmos is an awesome tool kind of showing you what's happening. So if you just want to graph these and look at the characteristics from the graph, that is awesome. I still need you to know this formula because we will need it later on. But I would double check with the graph. You do have homework. So if you look in Google Classroom under Wednesday, February 12th, it's called 11.2. Attributes of quadratics in standard form. So these give you graphs. So you can kind of tell from here, y-intercept would have to be over 0, up 3 because of that c term. So I'm looking for a y-intercept of 0, 3. Well, this one has 0, negative 5. This one has 0, negative 5. So I know I'm down to option 3 or 4. Then from there, it has to do with the vertex. So 1, you can use the formula we did, or plug this into Desmos and see what's happening. So x squared minus 4x plus 3 minus 4x plus 3. And I can look, my vertex is at 2, negative 1. So I'm looking for the one that's at over 2, down negative 1, so option 4. So I think it's a good way to do these graphing ones. You can do them all like that. This is kind of what we did on the notes. So does this parabola open up or down? Well, it's a positive a, so it's going to be opening upward, right? What is the equation for the axis of symmetry? So you have to do the stuff that we did. What is the vertex? Is it a max or a min? Y-intercept, domain, and range. For domain and range, it's listed a little bit differently than what we're used to. So in this case, if your domain was, here, let's use this one for example. Domain is always the all real numbers, so they're going to list it like this, negative infinity to positive infinity. These two things mean the same thing. So if you see that, that's what that means. With the range, y is greater than or equal to negative 11. That means that they're going to use negative 11 in a bracket because that's as far as it goes. We're including negative 11, and it goes all the way to positive infinity. Again, these two things mean the same exact thing. So that's how that's written out. If you have any questions, you can send me an email about that. Just a different way to write the domain and range. Same thing here. These, use the information provided to write standard form of equation. So option 1 would be to graph these in Desmos and figure out which have the vertex of negative 3, 5. So like I'd graph x squared minus 6x minus 14. 6x minus 14. And I would look at the vertex. This one's at 3, negative 23. Well, that's not the vertex. I know one's not it. So you can just graph them into Desmos that way for those two. This one you're using this formula here. It says how high is a projectile after 1 second? So your t is your time, right? So I'd plug 1 into here for my t and figure out what it would be. So negative 16 times 1 squared is just negative 16. Negative 16 plus 64 is 48. So I would just type in 48, and it'll accept 48, or if you want to type in like 48 feet, that works too. But it'll accept either one of those. And you would keep doing that for all of those. Okay, let me know if you have any questions. Y'all have a great rest of your day. Bye, y'all.